Okay, question 24. There are some counters in a bag. The counters are red or white or blue or yellow. Bob is going to take a counter, a random counter from the bag. The table shows each of the probabilities the counter will be blue or it will be yellow. So if these ones are filled in, there are 18 blue counters in the bag. Okay, we can come on to that in a minute. And the probability that the counter Bob takes will be red is twice the probability that counter will be white. So what we already know is that means the red, there's lots of different ways of doing this. We could have the red and the white, and it says the probability the counter Bob takes will be red is twice. So we could say, well, that's worth 2, and white is worth 1. That would be 2 to 1, almost like a ratio. Okay. And we know if we add these up here, 0.45 plus 0.25 is equal to 0.7, which means these two here must add up to 0.3, because we know all the probabilities must add up to 1 or 100%, that being 30% and this being 70%. Going back to our diagram, we know that has to be equal to 0.3. There's 3 of them, so each one must be each box must be 0.1. And then we have our probabilities. Red would be 0.2 and white 0.1. So putting those in, it hasn't asked us for that actually, has it? But we're going to need that to work out the number of red counters in the bag. So I'm going to put that in there. Red 0.2, white 0.1. Okay, what other information have we been given? 18 blue counters in the bag, 0.45. So let's write that down, 0.45. Well, we know that that's 45%. So 45% is 18 counters. And we could represent that. How could we represent that? 45% is 18 counters. We want to get to 100% to work out how many counters are already in the bag, or just for red counters 0.2. But I think 100% would be good. So easiest way to do that is probably to go to 5% by dividing by 9. That would be 2 counters. 100% would be times by 20. So 100% would be 40 counters. Okay, the red is 0.2, which is 20%. In fact, actually looking at it now, if we know what 5% was, and we know red is 20%, that would be our 5%, our 2 times 4, because that's 5% times 4, isn't it? That would give us 8 counters. Not the only way to do it, but quite a nice way to show what's going on there. Part B, a marble is going to be taken at random from a box of marbles. The probability the marble is silver is 0.5. There must be an even number of marbles in the box. Explain why. Well, to get 0.5, half of something would be silver, wouldn't it? So it says the probability the marble will be silver, half of the total will be silver. So what does that mean? Well, you can only take half. The total must be an even number because we happen to divide that by 2. The total must be even. Or we would get half marble in our answer. I'm not sure that's totally clear what we're saying there, but the total has to be even, because if half of them, the probability of the silver is a half, that means the silver ones must be, we also have a whole number of silver marbles. If it was odd, an odd divided by 2 would give us something 0.5. Think about it, if there were 7 marbles altogether, 7 divided by 2 would give us 3.5, and so on. 25. Solving in equations. Well, the problem with this equation, there's lots of ways to go about this one, but the problem with it is this 2 here. So we're going to get rid of that straight away. So we draw our lines, and we're going to times both sides of the equation by 2. That means the left-hand side will become 5 minus x. The right-hand side, we're going to have to times both parts by 2. So 2 times 2x, which is 4x, and 2 times negative 7, which is minus 14. Just about squeeze that in there. Now, it's the same as any question that we've done before, with x's on both sides. We get rid of the lowest amount of x, or the smallest amount of x, which in this case is minus x. So we're going to add x to both sides to get rid of that. That will give us a 5 here, and it will give us a 5x minus 14. What's stopping x be on its own? The 5 and the minus 14. So the next thing we're going to do is add 14 to both sides. Right hand side becomes 5x. The left hand side becomes 19. And stopping x be on its own now is 5. We should be able to simply see that we're dividing by 5, which is 19 over 5. Now that in itself is an answer which is fine, but you could also do the 19 divided by 5. 19 divided by 5 would be 3.8, I think it works out to be. There's never any harm in checking with your calculator there what you're going to get. So 3.8 is correct. However, either of these answers would be correct when you put them on the number line. Question 26. Question 26. ABCDE is a pentagon, 5 sides, 1, 2, 3, 4, 5. BCD is 2 times angle ABC. BCD is this angle here. BCD, so this one here is twice ABC, which is this angle here. Okay. Work out the side of BCD. Okay, well, we really need to work out all the angles here. And that means we need to know the interior sum of angles of a pentagon. Now you may know it, but there's always a good way to work it out. If you take a vertex, doesn't matter which vertex you take, so I'm going to take this one here and join it to every other vertex. That one's already joined. And E to C and E to D is already joined. So how many triangles have we just made? 3. Okay, so the interior angle sum is 3 times 180 degrees, because each triangle's got 180 degrees in it. So actually they've got to add up to 540 degrees. Okay, so how are we going to find these two angles then? Well, so far we've got 90 plus 115 plus 125 has been used up already. So that gives us, what's that? Let's do that. 240. Let's just check it. 90 plus 115 plus 125, which gives us 330 degrees. So two remaining angles must be what's left, 540 minus 330. Which gives us 210 degrees. And this is where we can use the bar diagram again, because we know that this one here is twice as big as this one here. So let's call that BCD. BCD is worth 2, and ABC, let's put the angle sign so we know they're angles, is equal to 1. So every time we get this ratio, of 2 to 1 or twice as big, we can always use, or 3 times as big, we can always use this bar diagram. Now we know it adds up to 210 degrees. That must mean that each of these blocks is 210 divided by 3. Again, you check on your calculator, but that's 70 degrees. And it asks for BCD. We can see clearly now BCD is 70 plus 70, which is 140 degrees.